solve one more problem, but before that, please subscribe to my channel and watch the videos online. Next example. Let f of x equal to e to power of x and p of x be a function ep in Pn. I mean a polynomial of degree at most n. Okay? And let p of x interpolate f of x at n plus 1 nodal points, namely x0, x1, 2, xn. All of them belong to interval -1 and 1. Okay? And let the absolute value of e of x, and let one of these nodal points be x equal to 0. I want to show that absolute value of e of x, which e of x is the error, I mean the difference between f of x and p of x, is less or equal to power of n plus 1 over n plus 1 factorial times e. Okay? And this will be true for all x between -1 and 1. Okay? Now, let me try to solve the problem. We know that by the error formula for the Lagrange interpolating formula. Okay? We know that error e of x is equal to w of x over n plus 1 factorial n plus 1th derivative of eta x, okay, where we know that w of x is pi I from 0 to n x minus xi, and we know that there exists a eta of x belong to interval -1 to 1. Okay, this is the formula that we know from the course. Now, take absolute value from the both sides of this equality. Okay, taking absolute value gives absolute value of e of x is equal to absolute value of w of x, absolute value of n plus 1 derivatives of f at eta x over n plus 1 factorial. Okay? Now, note that f of x equal to e to power of x. And this means that n plus 1th derivative of x is again e to power of x. Okay? So the n plus 1th derivative of eta of x is equal to e to power of eta of x. Right? So we can write here absolute value of w of x, and we can put instead of this one, e to power of eta of x, and we know that this value is positive, so we can ignore, or let me put the absolute value, no difference, okay, over n plus 1 factorial. Now if you consider w of x something like this, okay, in fact the multiplication of n plus 1 parenthesis, okay, and you can consider for each parenthesis an absolute value, so you can get absolute value x minus x0 times x minus x1 times x minus x2, and it continue until the x minus xn over n plus 1 factorial, okay, times absolute value e to power of eta x. Now two things. First of all, because xi is between minus 1 and 1, okay, and this gives and x is between minus 1 and 1, so it gives x minus xi should be greater than or equal to minus 2, less or equal to, and this gives absolute value x minus xi should be less than 2 for I equal to 0, 1 to n, okay, so I can get this one is less or equal to 2, this one less or equal to 2, this one less or equal to 2, and it continues until less or equal to 2, okay, and also we know that eta of x is between minus 1 and 1, so it gives that e to power of eta of x is greater than e to power of minus 1 less than e, okay, so this gives absolute value e to power of eta of x is less or equal e, okay, so for this one also I get this is less or equal e, okay, so finally I can, if I rename this one a, I can conclude that here 2, 2, 2, 2, how many? 2n n plus 1, so it will be less or equal 2 to power of n plus 1 over n plus 1 factorial times e, and this get the desired result is less or equal 2 to power of n plus 1 over n plus 1 factorial times e, and this is exactly what we want to prove, and this complete the proof. So this is another problem. Please subscribe to my channel and wait for the next lecture. Thank you and wait.